Oracle Database 23 AI introduced AI vector search. Let's have a look at how Exadata accelerates AI workloads with AI Smart Scan. In this short session, we're going to cover the unique AI vector search capabilities available on Exadata, including an overview of AI Smart Scan, optimizations including adaptive top K, binary vectors, and vector distance column projection, and what's new in Exadata System Software 25 AI, release 25.2. Oracle AI Vector Search can be transparently offloaded to Smart Exadata storage for faster search results. It's automatically parallelized across multiple storage servers to give the best performance for AI workloads. Each storage server independently computes the top K matches, and the database then merges the results sent from each of those storage servers. This results in up to 30 times faster AI vector search queries. Importantly, Oracle Database 23 AI and Exadata support multi-user environments with the ability to offload thousands of concurrent AI vector searches. AI vector similarity search retrieves the top K vectors ranked based on the vector distances. Adaptive top K filters vector data before sending the final results to the database server for more processing. This means that when scanning data, each storage server maintains a local running top K of the shortest vector distances for that query. Vectors with a larger distance than the running top K are filtered out and not sent to the database server at all. An adaptive top K is continuously updated as smaller distances are found. This results in up to 4.7 times more data being filtered by AI Smart Scan. Let's take a look at an example. In this case, we're asking the storage servers to give us the top 3 rows, or the top K of 3 for this particular query. So when it's sent down to the storage servers, an AI Smart Scan scans the first region and discovers that the 3 closest vectors in that region are 10, 20, and 30, it will set the adaptive top K to those values, 10, 20, and 30. When it moves on to the next region, we do the same thing. We scan the region, calculate the 3 closest vectors, and only if those vectors improve the adaptive top K will they be included in the adaptive top K. So you can see here vector 25 pushes vector 30 out of the adaptive top K results. Vectors 35 and 45, because they don't improve the query, are discarded altogether. They're filtered out. And we do the same in region 3 and so on and so forth. And in region 3's case, we can discover all 3 of the vectors are actually filtered out because they don't improve the adaptive top K results that we've gathered so far. Only the results that are in the adaptive top K are sent back to the database server for further processing. The use of binary vector formats is becoming more common in embedding models due to the space efficiency and good accuracy or recall that they provide. Oracle Database 23 AI vector data types support float64, float32, int8, and binary dimension formats. In binary formatted dimensions, each dimension is represented by a single bit, a 0 or a 1. The vector is represented as a packed uint8 array, meaning that 8 dimensions are packed into a single uint value. The vector size is therefore significantly reduced, but good accuracy is still maintained. AI vector search queries of binary or int8 vector dimension formats are offloaded with AI Smart Scan in Exadata System Software 25 AI, release 25.1. As you can see from the example on the screen, creating a binary vector is as simple as adding the binary keyword into your create table DDL statement. For reference, float32 is up to 30 times faster on Exadata with AI Smart Scan and maintains over 96% accuracy. int8, in contrast, is up to 8 times faster with AI Smart Scan than float32, again maintaining that 96% plus accuracy. Binary is up to 32 times faster with AI Smart Scan than float32 and maintains a very good accuracy of well over 92%. This results in up to 32 times reduction in storage footprint compared to float32, up to 40 times faster distance computation, and an accuracy of well over 90% compared to float32. AI Smart Scan automatically calculates vector distance on the Exadata storage servers. This frees up database server CPUs by offloading compute-intensive vector distance calculations. And for queries, such as the one on the screen below you, that need the vector distance returned to them, the calculated distances are now projected back to the database server as a virtual column. This reduces network traffic by eliminating the need to send large vectors from the storage servers to the database and avoids recalculating vector distances in the database server. This leads to up to 4.6 times faster queries and 24 times reduced data returned to the database. Mission-critical and analytic queries combine relational business data with AI vector similarity search. Let's create a table called houses, and in that table we'll have columns such as zip code, price, and a description vector. We then create a neighbor partition vector index called house_IDX on the description vector column. Note, however, that the price and zip code columns are not included in this index. So when we query for the top 10 similar houses and filter by price and zip code in addition to the vector distance comparison, evaluating the predicates on price and zip code requires lookup of the base table, in this case houses. Evaluating the approximate search on the description vector requires a scan of the neighbor partition vector index. As you can see from the explain plan, the attribute filtering for price and zip code on the base table are performed by row ID access, creating additional single block read I/O. New in Oracle Database 23 AI release update 23.7 and Exadata System Software 25 AI release 25.2 is the ability to include additional columns in our vector index. With included columns, we can directly evaluate attribute filters along with the vector search. This means that when the index contains all columns required for a query as included columns, data can be retrieved directly from the index, accelerating query performance. Let's recreate our house_IDX index in this case and include the price and zip code columns, as you can see on the screen. When we now search or re-execute our query, price is retrieved from the included column in the vector index, and filtering on price and zip code are also directly evaluated using the included columns. This leads to up to 3 times faster queries using included columns. We can also see that we've eliminated the row ID base table lookups in the explain plan. Sparse vectors have a large number of dimensions, but only a very few non-zero dimensions. They're generated by sparse encoding models such as SPLADE and VM25. And conceptually, dimensions of a sparse vector map to keywords in a vocabulary, such as the cat sat on that. A sentence, therefore, of cat sat would result in a sparse vector of 0, 1, 1, 0, 0. This is significantly faster to search with sparse vectors than with dense vectors. Again, it's very easy to create a sparse vector by including the sparse keyword in the create table statement or alter tables DDL statement that you might use. And inserting into a sparse vector is as easy as adding an array that includes the maximum dimension count, the non-zero dimension positions, and then the non-zero dimension values for that particular vector. And processing of these sparse vectors is offloaded to AI Smart Scan and therefore the Exadata storage servers as well. Let's recap quickly. AI Smart Scan automatically and transparently offloads AI vector search to Exadata storage and accelerates AI workloads. Its extreme performance is visible with adaptive top K filtering more data on the storage servers, binary vectors reducing vector storage and accelerating vector distance computation with extremely high accuracy, vector column projection boosting query performance and reducing data sent to the database. We've also covered the latest innovations in Exadata System Software 25 AI, release 25.2, with included columns in neighbor partition vector indexes, which accelerate queries and eliminate additional I/O, and sparse vectors, which boost query performance for keyword searches. Thanks for joining me on this brief overview of Exadata AI Smart Scan.